Unit 5A, Lesson 1, Properties of Rational and Irrational Numbers. So we're going to refresh on what rational numbers are, irrational numbers, some examples of each, and then we're going to perform operations involving rational and irrational numbers. First, we need to discuss or refresh the definitions for each type of number. A rational number can be expressed as a ratio of two integers, 7 over 2, negative 13 over 54. Any integer over an integer, that is a rational number. This includes decimals that terminate or repeat. Terminate means that decimal comes to an end. For example, if we had 1/8, this is an integer over an integer, that's a rational number. We could express this as 0.125. So even though this is a decimal, it's a decimal that terminates, it comes to an end. That is a rational number. If we had 1/3, we know that's an integer over an integer. That is still a rational number. If I could get this 3 to show up, we would express that as 0.3 repeating. That's a decimal that repeats. So by definition, that is still a rational number. Irrational numbers, this is a good definition, cannot be expressed as the ratio of two integers. This includes radicals that cannot simplify, the number pi, the number e, and decimals that don't terminate or repeat. So it includes all types of radicals I won't simplify, radical 2, the number pi, anything including that decimals that go on forever. You would see that as 0.01275, and then if we had the ellipses at the end, meaning that number is going to go on, there's no decimal here that's repeating, so that would be an irrational number. Next, we're going to discuss the possible outcomes that can occur with basic operations with rational and irrational numbers. The sum or product of two rational numbers is going to be rational. So if we add two rational numbers together or multiply two rational numbers together, that result is still going to be a rational number. The sum of a rational number and an irrational number is going to be irrational. And then the last one, the product of a non-zero rational number and an irrational number is going to be irrational. And you'll see some of those results as we go through examples involving actual operations on these types of numbers. Now to an example, we want to perform the indicated operations on the two numbers we have. We have the square root of 150 and the square root of 24. When we're going to perform operations involving radicals, which are irrational numbers if they cannot simplify down completely, we first want to simplify each of those radical numbers. The square root of 150 simplifies down to 5 times radical 6 because it's radical 25 times radical 6. Radical 25 simplifies down to 5. The square root of 24 simplifies down to 2 radical 2 because it's square root of 4 times square root of 6. Square root of 4 simplifies down to 2. So now the first operation we want to find is the sum of these two numbers. We have 5 radical 6 plus 2 radical 6. We treat that radical the same way we would a variable. So if we had 5x plus 2x, we would just add the coefficients in front to get 7x. The same thing here. If we have 5 radical 6 plus 2 radical 6, we add the coefficients together in front to get 7 radical 6. Similar idea if we have the difference, we take 5 radical 6 minus 2 radical 6. That's a good radical sign. Same idea as we have with the sum though, we're just going to combine the coefficients, so we take 5 minus 2. That difference is 3 radical 6. Now we have to move on to the product. We have 5 radical 6. Lots of times they'll put this in parentheses, times 2 radical 6. And for this, we're going to multiply our two values out in front, the coefficients together. So 5 times 2 would be 10. And then we're going to multiply our radicals together. Radical 6 times radical 6 is the square root of 36, which simplifies down to just 6. So we have 10 times 6, which we can simplify down to 60. So when multiplying those two irrational numbers together, multiply the coefficients together, multiply the radical portions together, and then multiply those two products together. And then the last one is the quotient. So we have 5 radical 6 divided by 2 radical 6. Anything divided by itself simplifies, so we cancel out the square root of 1 and the square root of 6 and the square root of 6. Anything divided by itself is 1, so we're just left with 5 over 2. So when performing operations involving irrational numbers, radicals, make sure to first simplify those radicals before finding the sum, difference, product, and quotient. Now to the second example, which is the same idea. Find the sum, difference, product, and quotient of the two irrational numbers. We have radical 15 and radical 6. First thing we want to do is simplify each of these radicals. The square root of 15 has no factors that are perfect squares. 6 has no factors that are perfect squares. We cannot simplify these. So we go ahead and try to take these sums. So we have the square root of 15 plus the square root of 6. And that is our final answer. We have no radical that is the same like we had in the previous problem where we had radical 6 in each of them, so we cannot combine these two sums together. Same thing when we take the difference. We have radical 15 minus radical 6, and that is our final answer. We cannot simplify and combine those two radicals. Next, we're going to take the product. So we have the square root of 15 times the square root of 6. Well, 15 times 6, that would give me the square root of 90. Now I can try to simplify that. I know that breaks up into the square root of 9 times the square root of 10. The square root of 9 is 3. So I can rewrite that as 3 radical 10. So when taking the product, we can actually simplify that a little bit. And then the quotient, we have the square root of 15 divided by the square root of 6. And one thing they're going to do when you take the quotient of irrational numbers, it's a process called rationalizing the denominator, meaning they don't want a radical in the denominator, so we have to somehow create that denominator or make it have a rational number, an integer. So one thing we can do is multiply by radical 6 over radical 6. This expression that we're multiplying by, anything divided by itself is 1. If we multiply a quantity by 1, we still have the same value. We're just rewriting it in a different form. Well, we know radical 15 times radical 6, we just did that. That numerator simplifies down to 3 radical 10. And the denominator, if I take the square root of 6 times the square root of 6, that's the square root of 36, which is just 6. Now I can simplify my 3 and 6. So I end up with the square root of 10 divided by 2. Taking the sum, difference, product, and quotient of irrational numbers.